I welcome you all to the 1 week online webinar on first principle, quantum transport, material simulation and battery simulation, and drift diffusion for solar cell and OLED. In 1 week, you can learn about the quantum chemistry softwares and first principle software like DSPOR, Rescue, NanoDecal, and NanoSkim software. And we also learn about the QTCAT software, which is used for the spin qubit devices and superconducting qubits. And also learn about the SetForce software and law software for the solar cell. I am Ujjwal Pratap Singh, an application engineer from Impulse Technology. Before moving to the software part, let me brief about our company, who we are, who are our partners and customers. Impulse Technology provides cutting technology for the nanoscale material and device also. And they offer for the TCAT and QTCAT software for spin qubit and superconducting qubit software, and also for the solar cell. And we are partner with three companies. First one is Fluxing, which is a Switzerland-based company. They offer software for the LED, OLED related technology. And second one is Nano Academic, which is a Canada-based company. They offer material-based and atomistic quantum technology software. And the third one is HJW, which is a China-based company. They offer software for the DFPT and AWS-based software also for the simulation for the nanoscale material and nano devices also. And you can see the our customer also like 70 plus university uses our software like NICE, National Institute of Solar Energy, VIT, SRM, IIT Madras, and IIT Dhanbad also. Here you can see the product also. Like for the modeling and visualization, we can use Device Studio, and for the DFT based Rescue and DSPOR, where we simulate the material based properties. And for the quantum chemistry, we will go through the MOMAP and BDF software, where you can find the property related to the molecules. And for the transport properties, we can use NanoDecal software and NanoSkim softwares. For the solar cell and OLED, we go through the SetForce, Lavos, and Opixis software. And the last one is QTCAT, which is used for the spin qubit devices and superconducting qubit devices. Let me go through the first software, which is SetForce software. SetForce basically used for the organic and perovskite solar cell, photodetector, LED, and it will come with the 5 module like absorption module, drift diffusion module, advanced optics, emission, and thermal module. In absorption module, you can find coherent, incoherent layer, absorption profile, energy yield analysis you can find. And in drift diffusion, you can go through the electronic charge excitation, ionic charges, hopping, and polar layer also. And in advanced optic, you can go through the quantum dot down conversion and the scattering at texture interface also. In emission module, you can find the mode analysis, quenching, spectral emission also. And newly added module, which is thermal module for the OLED degradation and optic heating also. And the second software is Laos, which is used for the large area semiconductor devices like organic perovskite solar cell and LED also, where it comes with the 3 module like electrical module and thermal module and optic module. In electrical module, you can optimize electrode design, also reduction of electrical losses, and you can understand about the electrical crosstalk in OLED pixel array also. And in thermal module, you can find OLED, solar cell, and understand operation also. In optic module, you can find crosstalk in OLED display and 3D ray tracing algorithm also. Like you can analyze electrical losses in large area electrode for LED and PV module also. You can calculate the temperature distribution and quantify the pixel crosstalk effect also, and simulate the impact of defect and shut on the device operation also. And the third one is Opixis software, which is used for the display research and development also, where you can use for the OLED, QLED, micro LED, and other advanced display technology, where you can find the power consumption statistics and influence from the form factor like subpixel ratio and other effect also. And the first one is a QTCAD software from a Nano Academy, which is used for the quantum technology computer-aided design tool for a spin qubit devices and quantum dot also, where it combined with the electrostatic, quantum mechanical, and semiconductor physics using finite element method, where you can use the design for a superconducting qubits, and it also integrate with the atomistic simulation for the Joseph junction also. Here you can see like superconducting qubits, adaptive meshing, in-house adaptive meshing algorithm. You can design the quantum dot region and new tool for the visualization and builder for your quantum dot devices. And you can also do the atomistic modeling in QTCAD software, and you can do quantum transport properties using QTCAD. Now, let's talk about the Device Studio, which is a material design and simulation platform where you can use to create your material file, device also, and you can simulate here in the Device Studio. It is integrate with the multiple simulation software like PDF, where you can find the quantum chemistry calculator and the MOMAP for the OLED prediction like photocatalysis, and DSPO also, which is first principle calculation, and you can see the rescue for a material based software, and you can also use DASP, defect and impurity first principle calculation software. It means at single platform you can use these all type of software for a quantum chemistry also, for material based software also, and defect impurity first principle calculation software also at single platform to the GUI option. And it also integrate with the quantum transport properties like nano decay, which is used for the nano devices, where you can use for a gas sensor and other application also, where you can create the left electrode region, right electrode region, two probe devices, four probe devices you can create at a device studio, and you can simulate also at a device studio. And here you can see nano scheme, which is tight binding quantum transport calculator. For a, you can design like MOSFET and CSFET also. Let's talk about the rescue software, which is a used for a material-based software. It is based on density functional theory and density functional perturbation theory, where you can find the property related to the DFT parameters like dielectric tensor, optical property. You can find the phonon property, Raman, tensor, and electron phone coupling you can also find. It also come with the exchange correlation function, like hybrid exchange correlation function is also come, like HC06 and meta GGA LDA also, and it also integrate with the live exchange correlation function. You can also introduce DFT plus U Habardio term in the material based software, and it comes with the electronic structure like you can find band unfolding, band projection, Mulliken charging, the earth projection, and you can find the magnetic property also, like it can introduce collinear, non-collinear, and spin orbit coupling also. And you can find the mechanical properties like state analysis, Trojan phonon method, and equation of state also. You can see the application case also here. You can design the more pattern simulation, and you can simulate in a device studio through the rescue engine. You can see some of the application here like career mobility simulation through the rescue software, and you can find these type of properties related to the rescue software like density of state, charge transfer simulation, and water molecule dipole analysis like charge analysis. All these graph taken from the research paper, which is using rescue software. Here you can see also for a nanotube, carbon nanotube, and find the property like band structure also, density of state, local density of state also, and find the Berry curvature for a LOMO and HOMO also. Now let's talk about the nanodecay software, which is used for a material and device both. It means you can simulate the material also, and you can simulate the device also here. It is based on density functional theory and NEGF, non-equilibrium gain function, to find the transport properties, quantum transport properties. It is written in MATLAB and C. It means some dependency on MATLAB also for it to show the result only. And its core capabilities are like thermoelectric module, optical module, electronic module, phonon module, and you can find mechanical module also. Like you can find full energy band density of state, local density of state, projected density of state you can find, and you can find IB curve, photocurrent, charge, eigenstate, electron density you can find. And in phonon band, you can find phonon density of state, transport channel also, and dynamical metrics also. Like in application case, you can see you can create these type of devices also, like bimolecular devices, like left electrode region, right electrode region, and center region. You can see scattering region. You can also do the rotation of your devices also, and like flexible of device, and you can change the angle also in the device to your GUI. Here you can see some of the example also, like gate control, quantum interface, effect in single vault, carbon nanotube PN junction also. Same for the two-dimensional flexible devices, and you can find the property related to that also, like transmission, IB curve, and other parameter also. In the same way, you can find the bimolecular devices properties, and you can create also gas sensor, like find the transfer of a gas on any sensor and find the properties also. Now let's talk about the DS4, which is also first principle calculation software, which is based on plane waves, and it come with the function and correlation like LDA, GGA, and it also integrate with DFTU, and you can introduce van der Waals interaction also, and you can find the properties like DOS, P-charge, band unfolding, Fourier function also, and you can relax your structure, and you can introduce like magnetic properties like collinear, non-collinear, and linear response also. And you can find like this type of graph also, total density of state and projected density of state for a gallium nitride and other material also. You can see some of the example here, like for the charge analysis, thermodynamics also. And you can find the phonon properties and molecular dynamics also. Like you can see the structure stability diagram. Now let's talk about the quantum chemistry software, which is BDF, where you can find the ground state and excited state also for a single point energy. It basically used for the molecular system with very strong focus on relativistic electronic structure theory. And you can find the spectroscopy like NMR, also X-ray absorption and electronic circular also, and Raman spectroscopy also. You can find the excited state calculation with the time dependent DFT also, like FLMO time dependent DFT, and you can see the spin matching method also here present. And you can introduce the response properties and scalar relativistic effect and spin orbit coupling also. You can optimize your molecular structure, and you can find the energy and charge transfer also. When we go through the demonstration of a video software, we go through the all these type of parameters also. You can see the application case for a VDF software. Here you can see the absorption spectroscopy analysis also, and natural transition orbit analysis here through the VDF software. You can see the spin orbit couple computation also, and optimize for the energy interaction also. You can find like vibration frequencies calculation also, and you can do for the large system also. And you can do the structure optimization for the spin mix method also. Now let's talk about the MOMAP software. Basically, MOMAP is a post-processing and simulation platform for a predicting photocatalysis property of a molecular material, basically for a OLED and organic optoelectronic properties like excitant dynamics, charge transfer. You can find like photocatalysis, photophysical property calculation like vibronic coupling, radiative rate, absorption spectrum. You can find emission spectrum. You can find, and in transport property calculation, you can go through the carrier mobility, electron transfer rate, recognition energy also. You can see some of the example here related to the research paper. They are using the MOMAP software to find all these type of parameters. like Lumo Homo parameters. Same here you can see also some of the paper you will also attach for a MoMap software. Same for the OLED, you can see the emission modules. Now let's talk about a nanoscale software, which is a tight binding quantum transport calculator, where you can use the core capability for the device doping, and you can find the transport properties related to that. You can find the IB curve, electronic transmission spectrum, electron phonon coupling also you can find, and you can create uh, ring gate type silicon nanowire transistor also, and find the transfer characteristic band structure also. Like you can create MOSFET and transistor like devices also, and you can find the property related to that. Here you can see our services also, like we can offer the single user and multi-user licensing. We can also offer cloud license. If anyone want the cloud license, like if system is not up to mark, you can also go for the cloud, where you can use the parallel processing for the software also and simulate at the minimum time. Like we can offer AWS cloud software for a calculation engine and DFT calculation you can see here. Now let's move to the Device Studio GUI, where we can simulate our first example. Here you can see the interface come for the GUI for the cloud. You can see here. Let's go for the offline this time and create a new project first. Give the name here. Material file. Create your material file also. At the top section, you can see the menu bar like file option, edit, view, build, simulator, window, and help. If you go to the simulator option, you can see some of the software given here, like NanoDecay software, NanoScheme, Rescue, BDF, MoMap, and DS4. It means at a device studio GUI, you can use all these type of softwares. And it also integrate with the like WASP. If you are using WASP, this is a GUI where you can create the input file for the WASP also, and Gaussian also, and WCHM also, and Quantum Espresso also you can see here. It means you can use also as a GUI for other software also, like for a WASP, Gaussian, and Quantum Espresso also. At the below section, you can see the project, where you can see the pipeline of a project. It means the folder where you can import your material file here, and you can see the property related to the material file here, like lattice area, their coordinate in the property section. In the job manager, you can see the your script in running condition or queue condition, like the status of your input file here. Here you can see the visualization of your material file, and here you can see the toolbar option for the material file, like delete, add, or replace atom. Let's first import any material file. Go to the file option. Here you can see new project. You can click on new project, open your existing project. You can save your project. At the import option, you can see import local and import online option. If I click on import local, here you can see Device Studio offer 500 plus material database. You can see here 3D material, organic material, 0D material, 1D material, 2D material. If I go through the 3D material, you can see some of the folder also given, like semiconductor, insulator, layer material, magnetic material, metal oxide, novelty material, and conductor. If I go inside the semiconductor, you can see all semiconductor material present here. Same for the insulator also. You can see the diamond, NaCl, ZrCl3. Same for the layer material also. You can see some of the layer material like WSE2, phosphorus, and other material also for the layer material. In the same way, for the magnetic material also, you can see some of the magnetic material also present here, like metal oxide, and in novelty material, you can find the material for the perovskite also. You can see perovskite material and half metal also, and you can find the conductor material like pure metal. You can find iron, copper, or material here. You can find the organic material also. You can see organic material and zero D material like molecules. You can find amorphous and crystalline also. And same for the 1D material and 2D material. If you go inside a 2D material, you can find the graphene material also and some novelty material. And here you can also see our device would support wide range of material format also like XYZ, CIF, postcard, SCF input, relaxation, and molecule and PDB. It means apart from these material files, you can also import another material which is in this format like XYZ, CIF, XST, postcard, and molecule and PDB. For a time being, let's import the 3D material, then semiconductor. Now let's import the silicon material here. You can see silicon and click on open. Here you can see the structure of your silicon material file here. And you can see the properties also like their vectors and total number of atom you can see here and total area of lattice you can see here. Apart from that, if your material is not present in local database, it means in device studio database, you can directly import your material from online database. Here you can see import online option. If I click on import online, you can see here you can write your formula basically like MOS2. If I type, it basically fetch the data from material project here. You can see import from material project. Here you can see material MOS2 for a different space group. You can choose like first one. You can see also the description also here. And you can directly click on add. It means there is two ways to import your material file through the local database and the through online database. If material is not present in local database, you can directly switch to the import online option and type your formula and you can import the material file. And the third option is also given. If material is not present in local database and online database also, you can create your own material files through the crystal option like file, new, and crystal. You can see here crystal option. It means if the data is present related to that, like you have to give the space group here, brevis lattice, and their element also to create your own material file. Like if I give here, you can see the number of space group is present here. Like cubic face centered, and I've keep the brevis lattice here, like 5.62, and you can see the fractional coordinate also. If I click on plus icon, you can see by default carbon is selected. If I double click on carbon, it will open the periodic table. Here you can see. You can choose now any element. Like if I choose Na and click on OK. Again, if I click on plus and give the coordinate like 0 0.5, 0 0.5 for a P1, P2, and P3. You can see by default N is selected. Let's change to the chlorine. Here you can add n number of atom. Let's go for the two element basically here and click on conventional cell. Click on show equivalent atom and click on preview. It means through the giving the data like space group, brevis lattice, and element, you can create your own material file and click on build option. Here you can see the structure also for NaCl. It means there is three ways to import your material file through the local database and through the online database. And the third option is crystal. Through the crystal, where you have to give the space group, brevis lattice, and their coordinate also for the element. And you can create your own material file. Let's import any other material also, like graphene material. Go to the 2D material, and you can see the graphene. Click on graphene and click on open. Here you can see. If you go to the build option, you can see the redefine crystal option given to create like supercell structure. Click on redefine and you can give the value like 12 cross 12 preview. You can create this type of structure also for like graphene nano ribbon structure and click on build. For the home icon, you can see here, you can see the different view also like XY view, XZ view, YZ view, YX view, and ZX view. If you want to replace any atom like this one, you can directly click on this and you can see in now toolbar many tab are enabled now. You can see replace atom option. If I click, it will open the periodic table and choose any element like nitrogen and click on OK. In the GUI, you can see the color changes also. Here you can see. If I click this one, you can see the property also here, like nitrogen and their coordinate also. If you want to delete some atom, you can also do. You can by doing left click of the mouse and drag a box. It will select multiple atom and you can delete also. In the build option, there is option for a molecule and molecule 2D option. You can see at the top section. If I click on molecule option, it will open a new window where you can create your own molecule. Like if I click on plus, it will open the periodic table and you can see the different fragment also, like for a single carbon atom and tetrahedral carbon atom. You can see if I click on this and drag, you can see the structure also. By double click, you can add another tetrahedral atom also. Like this one. And you can change the angle also. You can see here, like modify bond. If I click on this, here you can see single bond, double bond. You can change the bond also here. And you can change the bond length also. Like you can fix the atom 1 and you can change the bond length through this. Same way, you can change the angle also, like modify angle. You have to select atom first, and now you can change the angle also, like this. After that, click on apply data to import your molecule in here. At the top section, you can see force field calculation. It basically minimize your structure, like molecule structure. Choose according to your molecular structure and choose any algorithm like GFF. According to your material file, you can choose the algorithm to minimize the structure. It will take some time to minimize. You can see it minimize the structure. Again, if you go to the build molecule option, here you can see some ring fragment also given here, like benzene ring and other ring fragment given here. You can choose according to your need also. In the same way, R group fragment given here, you can see to create the molecular structure and find the property related to that through the MOMAP software and BDF software. You can see some of the biomolecule fragment also given here. Like you can see the biological fragment. If I click this one, you can see some of the material for a biological fragment also given here. You can choose the type also first here, and you can see the structure. It means through the 3D molecular structure, you can import the molecular structure like biological fragment also, R group fragment and ring fragment you can import to the 3D molecular structures. Again, in the build option, there is option for the molecule 2D structure. If I click this one, you can see it will open the new window where you can create your 2D molecular structure. Like if I click on ring fragment, and create this type of structures. And if I click on apply data, you can see the like property also here, like bond, frame also, atom default also, bond default, their angle length also, their lone pair and radicals. You can also introduce here, you can see the hydrogen also and click on apply data. You can see the structure, it is not minimized. Click on GFF, it will basically optimize your structure. Again, go to the build option. Here you can see some of the given here like graphene nanoribbon nanotube structure also. If I click on graphene nanoribbon, you can create this type of structure like 2 cross 2, and you can see for a side take carbon is selected and side free carbon is selected. You can choose different element also by clicking on this. It will open the periodic table and you can choose any other element to create the nanoribbon structure also. Same for the side B, you can choose different atom if you want, and you can see the bond length also here. You can see 1.42 angstroms, and you can give the call vector here. Click on pip view and click on build option. If I go to the build option, redefine like 10, You can create this type of structure also, like graphene nanoribbon. Again, in the build tab, if you want to create a different type of nanoribbon structure, you can also do. Again, go to the graphene nanoribbon. Here you can see, let's choose the nitrogen here. Same for the side view also, and click on preview. Again, go to the build and create a supercell structure to create a proper nanoribbon structure. Click on build. If you want to create a multi-layer structure like nanoribbon structure, you can do the copy, select all. Here you can see the copy option, copy, and paste here. You can see the structure for graphene nanoribbon for a carbon and nitrogen also. You can also move the up and down also, like here you can see, move atom. You can give the distance also, like 3 angstrom. Now you can see, you can create this type of heterostructure layer. In the again build tab, you can see the some other option also, like graphene nanotube structure, where you can create a nanotube structure also, like graphene nanotube, and click on build. To create proper nanotube structure, you have to redefine and give the value like 10 angstrom, and you can create this type of carbon nanotube structure. Here you can also create the concentric nanotube structure. Again, go to the build nanotube, build graphene nanotube, and choose like nitrogen. And click on preview. Go to the build option, redefine, copy the carbon nanotube, and come to the 5 cross 5 nitrogen nanotube structure. Paste and select only the carbon nanotube. And you can see the some of the option here given, like center. Click on center. Now you can see the structure also, like carbon nanotube and nitrogen nanotube structure. It means through the device to the GUI, you can easily create your material file, delete or add atom, replace atom, create nano ribbon structure, nanotube structure. It easily you can do in a device studio. If I import any other material like copper, You can see here. If I go to the build option, you can see the redefine crystal option. If I click on redefine crystal, and if I click on face centered, you can see the face center structure of copper also, and click on build. And now time click on body centered, click on preview and build. Again come to the copper redefine and create a supercell like 4x4. Click on preview, click on build. You can see the structure also. Now let's in the same way create for the iron also. Go to the build option, redefine, and click on 4 and create. Click on build. You can see to create a device structure, you have to go to the file option and new. Here you can see the device option. If I click this on this device, it will open the structure to build like left right structure, left center and right, bottom and top, bottom center and top structure, front and back structure, front center and back structure also here. If I click on left right structure and click on OK, and if I choose the left electrode material here like copper and iron here and click on preview, you can see you can create these type of devices also where left electrode is copper and right electrode is iron also. Click on build option. You can see the mismatch percentage over here. Click on build. If you want to create convert to crystal, it means this is device basically left and right. You want to convert to crystal, there is option also like convert to crystal option. If I click this one, you can see you can assign the different type of structure also like orthorhombic, triclinic, user defined also, cubic also. Let's go for the user defined and click on build. You can see some of the atom are outside of the crystal unit cell. Drag a box and click on center. Now it's a crystal now. You can see again, if you want to convert to device option, you can see convert to device also given like left electrode, right electrode you can define. You can see it create a region like left electrode region, right electrode region. You can also change the length also like if I change here 4 angstrom, you can create a device, this type of device also. Again in the build tab, there is option of a Bending of device. It means you can bend also devices also. Like if I keep the angle here, you can see the bending method, one side and both side. If I click on both side and click on preview, you can see it bend your devices also. Preview. It create a bending of device also in device studio GUI, and you can create these type of devices also. Let's simulate a simple example through the rescue software and find the parameters also. Let's simulate the silicon material here. In the simulator option, here you can see rescue. Rescue is used for a material and it is based on density functional theory and density functional perturbation theory. If I click on rescue, you can see some of the options given here like self-consistent field calculation, relax, density functional perturbation theory, analysis, and analysis plot. First, you have to create a self-consistent field calculation to create some analysis also. Basically, it will generate the Hamiltonian and basic parameters to the self-consistent field calculation. If I click on SCF, you can see it will open a new window with same SCF calculation for crystal. Here you can see some basic settings like sigma value. You have to give the resolution and you can choose the method also like real space, linear combination, atomic orbital. Rescue based on real space grid also and linear combination atomic orbital also. And you can see the exchange correlation function. Here you can see multiple exchange correlation function given here like LDA, GGA, meta GGA, hybrid GGA, and HHA06 also given here. For a time being, let's go with the default one, LDA, and you can also introduce von Neumann also structure and K point sampling. You can also increase, and it also support GPU acceleration also. You can also include if you want. And in the same way, iteration control, you can see some tolerance level for a charge density, total energy also. And you have to assign the maximum SCF step, and you can see the method also, like linear, Broadband, Pooling method for a mixing of your variable also. In the basis set, you can see the silicon atom and the basis was double zeta polarized. You can choose according to user defined also. If I click on user defined, you can also give your own basis set. Like here you can see in NAD format and MAD format. Device Studio also offers some basis set also. You can see rescue atom database and some pseudo potential also. From through this, you can also give the basis set also. Like you can see here. For all element, it also gives the basis set. For a time being, let's go with the default one, double zeta polarized. And you can also include the Havardu term, like LDA plus U. Here you can see for a rare earth element, you can give the value here. And same for the spin type. You can choose collinear spin, general spin also for a magnetic material properties. If I click on general spin, you can also introduce spin orbit interaction also. For a timing, let's go with the no spin and click on generate file. Here you can see the project folder. It created some folder like silicon folder, then rescue crystal, and in rescue crystal, there's input file like SCF input file and atom.xyz. If I click on SCF input, right click, you can see it gives the option like run open with. If I click on open with, here you can see the script also, which is generated through the GUI for a self-consistent field calculation. Here you can see some parameters like info calculation type, self-consistent, and where the result will be saved in the result folder with name silicon STF. You can see the lattice vector, eigensolver empty band, and the algorithm using CFSI, and unit energy you can see electron volt, and the function using LDA exchange correlation function, and some coldness level, which is generated through the GUI. You can also change in the script if you want. Like if I change here, like 15, you need to the save here and cancel. In atom.xyz, you can see the coordinate of your material file for a silicon material. In our material file, there is only two silicon atom. You can see two silicon atom and their coordinate also given here. Let's run the SCF input file. Right click and click on run option. In the job manager, you can see SCF input file in running condition, and you can see the process by clicking on this. It will show the process of your SCF input file. It will take some time. For timing, let's go to the simulator option again, rescue, and you can see the analysis option. If I click on analysis, you can see you can find the density of states, band structure, molecular population, and potential. Let's find the band structure first. Here you can see the band structure, and you can see the path also, like symmetric K point. If I click on path, it will open the belowing zone path. You can also modify these point also. Like you can give the value different value also, and you can move up and down also by clicking on delete and move up, move down, and you can add also new. Click on preview and apply, and you can see the number of K point also, and you can find the partial weight calculate also. Click on generate file. In the project section, you can see it created the band structure input file. Here you can see. If I click on this, right click and click on open with, here you can see the script also for a band structure dot input file. Here you can see info calculation type band structure, where will be the result will be saved, like result and silicon band structure. If I copy this and remove the result folder, it will show the band structure here directly in the project section. And you can see the LCO status, various lattice like face centered cubic and K point sampling. Click on save and again run the band structure input file. Click on run. In the job manager, you can see SCF input file completed. Now band structure.input file in running condition. If I click on rescue log.out file, here you can see rescue log out file. Open with. You can see the information related to the material file like rescue version, pseudo potential, basis, and their lattice vector also. You can see some of the K point function, exchange correlation function, and you can see like generating local over local coverage indices and potential. You can see effective potential. You can see all type of this data in the log file also, and you can see the number of iteration for a self-consistent field calculation. Now let's close this, and you can see the band structure.input file in running condition. You can also see the process by clicking on this. Now it's completed. Here you can see band structure.txt file and density also file you can see here. Band structure, so view you can see the band structure file for silicon material file. And if you want to export, you can also export your material file, sorry, export your data in image, like multiple image format. And you can export your data in text format also, like export all data in text format. You can see the density also, 3D, 2D, and 1D structure. Again, if I go to the simulator, rescue, sorry, simulator, rescue, analysis, and in band structure, if I will find partial with band structure, click on this and click on generate file. You can see it created a new input file with band structure, partial with input file. You can see the script also. To save the data here, I have to remove the result folder first. And run this input file. You can see the job manager, band structure, partial width in running condition. You can see the process. It started now. You can see the K point and the differentiation also, and their value also in the log file. For a time being, let me go through the build option and show other option also. Here you can see interface builder option. If I click on interface builder, you can create different type of interface between two different material also. Like if I click on structure, you can choose here by clicking on three dot, and you can import material from a material database like 3D material, conductor, pure metal, AG, and for a structure B, let's import the AU material, gold, and you can create the interface between two different material also. You can see the some grid size also to create the supercell structure. You can change the angle also according to your need. Click on match. Here you can see total number of atom, rotation, mismatch, and other parameters also you can see here. And you can see the strain range also, like 100% strain surface for a first, second, and both surface. Click on preview. Now you can see the interface between gold and silver. Click on build. You can see. In this way, you can create the interface between two different material also through the interface builder. Now you can see in the job manager, it's completed now. Let's see the data also for a partial weight band structure. Right click, click on show view. Here you can see the SPDF also. And if I click on this, you can see the now visibly clarity also for a SPDF partial weight band structure. You can find these type of data also in the rescue software, and you can also export in an image and text format also. Again, if you want to create some different type of pattern like Mori pattern and other ABS stacking and other stacking, you can also create. Again, go to the build option and interface builder. Let's choose graphene structure from directly from the projects folder. You can choose graphene for structure A also and for structure B also. And like grid size give here 32 and 64, and give here angle like 1.03 and 1 point up to 0.9, and give the increment only 1 and click on match. You can see the mismatch percentage also here 0.07. Total number of atom you can see here. Rotation you can see 1.08, and you can see strain angle also here. Click on preview. You can create this type of pattern also in a device studio GUI and find the parameters also. Rescue support 10K plus atom. It means you can simulate up to 10K atom also for a large system, and it also support parallel processing where you can easily simulate easily and find the property related to the different type of patterns and material file also. If I click on build and click on different view, you can see the different type of pattern with angle changes, like some different angle. You can see Mori patterns. So this way you can create different type of pattern in device studio GUI also and simulate basically through the different type of material based software like rescue, nanodecal, digaspor according to your need. Like rescue is based on density functional theory and density functional perturbation theory, and nanodecal is used for a devices also and material also, which is based on density functional theory and non-equilibrium gain function. And third one is the DSPO, which is used for a plane waves, where you can use to find the molecular dynamics and other parameters also. Again, for the silicon, let's find the density of state and projected density of state also. Go to the simulator, rescue, and in analysis, you can see density of state. If I click on this, and let's increase the K point sampling to improve the accuracy and give the energy range like 5, and click on generate file. Here you can see in the project section, it created the density of state input file. Here you can see in the left side, you can see density of state input file. Right click and open with. Here you can see the script also for a density of state, like where it will be saved, like calculation type, density of state, save path, and where it will be saved. Let's change the parameters also here and remove the result folder from here. And run the density of state input file. In the job manager, you can see density of state in running condition. Again, let's create the input file for the projected density of states. Go to the simulator, rescue, and analysis. You can see density of state. Here you can see projected. Click on this. You can choose according to the atom also and angular momentum like L and M, and give the value here. Go for the 0 cross 1 1 and from -1 to 1 and click on generate file. Here you can see projected density of state input file, open with, and remove the result section, and basically to show the result here basically rather than in the result folder. Run this projected density of state. Now you can see density of state completed. Let's see the density of state first. You can see the density of state also for a silicon structure, and you can change the see the value according to the x minimum, x maximum also. You can see projected density of state also completed. To see the data, you can see like coordinate here, total density of state, s orbital, p orbital, and p orbital, x, y, z also you can see here. So this you can find a PDOS also for any material file, and LDOS also you can find, and simple density of state you can find through the rescue software. Again, in the rescue software, there is option for the density function of perturbation theory. If I click this one, you can see you can find phonon density of state, phonon band structure, and phonon density of state. Optical property you can find, Raman property you can find, and other parameters you can find here through the DFT parameters, density function of perturbation theory. If I click on optical property calculation, here you can see SCF method, real space, exchange correlation function, only two given here, LDA and GGA. Iteration control, you have to give the some value here. Basis set you can choose like double zeta polarized, and you can give your user defined also. Spin type and optic factor also like damping factor and electric field direction. Click on generate file. If I click on generate file, here you can see in the rescue, it created a new folder with name rescue density functional perturbation theory, where you can see the SCF input file, dielectric input file, phonon input file, optical input file. First, you have to run the SCF input, then dielectric.input file, phonon.input file, then optical.input file. You can see in the job manager, in running condition and in queue condition. For a time being, let me show the documentation also for the software. If you go to the Nano Academy Technology, you can see the first website where you can see the documentation related to the all software like NanoDecal, Rescue, and QTCAD. Here you can see documentation and tutorials. You can see the product also like NanoDecal, Rescue, and QTCAD. You can see the theory part also, tutorials also, and like you can find the STM also in the rescue software, scan internal microscopy you can find. In last, I also saw the STM related example also. And the second one is HJW.ai. You can see the product here, like Device Studio, Alchemist, quantum chemistry software like BDF, MOMAP, and DFT software, DSPO, Rescue, and for a quantum transport, you can see NanoDecal and NanoSkim. You can see the tutorial related to the Device Studio also, how to use the Device Studio by clicking on this. You can see the user guide and how to use the Device Studio, and their toolbar also option. For up to now, if anyone have doubt, please ask. Like if anyone have doubt related to the material file and other parameters also, they can ask. You can also write the query in the chat box also. Anyone who have query, please ask. Like if you want different material, please tell us.
Sorry, good afternoon.
Yes,
Is it
sir.
audible, sir?
Yes, sir. Yes, sir.
Is it possible to write bigger molecules, sir?
Yes, sir. You can easily simulate, but for a time being, we in demo session basically show the simple structure to show the result also.
Okay.
You can simulate
Okay.
in rescue
Right, sir.
up
So
to
if you want to
10K plus
contact
atoms, sir.
you like further,
Yes, sir.
okay, if you want to contact you further, so what about your details, sir?
Yeah. We'll give the details also at the end of the session.
Okay, fine, sir,
And
fine.
in rescue software, basically you simulate up to 10K plus atom. It basically designed for the large scale system also.
Okay. Right, sir, right. Thank you.
Basically, sir, in Device Studio GUI, you can simulate DFT based software like it is designed for DFT based. You cannot design the chip design here. You can create like simple transistor devices and find the property also.
Okay.
And for a battery related, you can use here, find the property related to the battery material file.
Hello.
Rakesh Kumar, sir. Yes, sir.
Hello. Yes.
You are audible, sir. Please ask. And for a battery, you cannot find the battery related parameter like discharging, charging. For two, you can find here battery material properties, not whole battery properties like charging, discharging. You can find property only related to the battery material only here. I hope you got your answer, sir. Yes, you can import any oxide material also through the file option, import, import local, and in 3D material, you can see some metal oxide, and you can choose here also according to your need. And in nanodecal, you can create gas sensor type of devices also, where you can find the absorption energy and charge transfer parameters also. Yes, it will work on the simple system also. If your system is from above the i3 and 4 GB RAM, you can easily simulate your example here also. But it will take some time. Let's move further. And
क्या बोल रहे कौन?
Now you can see for a optical related properties, it completed all. You have to open the optical.input file and write a parameter here.
चलो session complete.
Click on save and you have to rerun this optical.input file to see the data. If I open any project folder like this one, you can see open containing folder option given here. If I click on this open containing folder, here you can see it will show some result in mat format also, like silicon band structure .mat file and .h file. Basically, rescue and nanodecal written in MATLAB and C. To see the data only, you have to move to the MATLAB and see the data also. Let's open the MATLAB here. For a timing, let's open again build tab, and you can see here some other option, like you can create a disorder graphene like structure and disorder zinc blend like structure also you can create. If I click on disorder graphene like structure, you can see you can choose the different element also for the site A and site B also, and you can assign the bond length, and you can create a supercell structure like 10 cross 10 and click on preview. It will give the structure this type of disorder graphene like structure, and click on build. Again in the build tab, there is other option like disorder zinc blend like structure. You can choose different element also, and you can see supercell structure like this you can create also. Click on build. Here you can see if I select all atom and go to the build option, there is option of bond option also given. You can create the bond also here. You can see it created the bond also to the bond option also. Again in the build tab, there is option for the iCassette drawn, where you can increase the cell number and you can create this type of structure also. Like if I increase the cell also and choose the nitrogen here, you can create this type of structure also in a device studio also. Same for the Q vector drawn, you can create. You can choose different element also, and you can create this type of structure. You can increase the number of cell also, and you can find properties also related to the molecule also. Let's see, now it's open the device studio. You can see IR intensity and other parameters also. You can see the dielectric permittivity, IR intensity, energy loss. You can see the energy loss also, and refractive index. I saw some example also, which I earlier simulate. You can see the dielectric permittivity for a boron nitride I find earlier. IR intensity, you can see IR spectrum through the Raman properties. I find the IR spectrum also. Energy loss also, refractive index, phonon band structure you can see here for boron nitride, and phonon density of state you can see here. Raman properties, like for polarized, Raman intensity you can see. Same for Q1 and Q2. Basically, to see the DFT parameters result, you can move to the MATLAB and see the data also. Like you can see in result section, it created some mat file also. Like if I click on boron nitride optic.mat file, you can see their variable also like atom, DFPT, and functional information also. If I click on info, you can see the data also here. If I type DFPT, basically for a post processing and to see the data, you have to move to the MATLAB and see the data for rescue and nanodecay both. Let's move to the device studio and see the other feature also for a device studio. Again, in the build tab, there is option for a CAD to atomic option. If I click on CAD to atomic, it will open a new window where you can create two or different material interface. Like if I click on this and add, and if I click on calculation, it will open a new window where you have to assign the material file and the length also. Like if I click on this and choose material, from the conductor, AU, and you have to, 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 and you have to assign the length also, like 2 nanometer, let's go for 3 nanometer, 2 nanometer. Material file. You can and create a like and you can see and click on build. I hope my screen is visible to everyone. Please confirm.
Yes.
Here you can see you can create a device also for the molecular structures and click on build option. And if you go to the simulator option in nanodecal SCF calculation, you can find the electrode region also, like defined parameters, and you can find the property related to the nanodecal also here. In tomorrow session, basically we also go through the nanodecal software where we can find the property related to the biomolecular devices and IB curve you can find, transmission spectrum you can find, and other parameter in the nanodecal software you can find. Here you can see it convert to the device. Now if you want to convert to the molecule, here the option also convert to molecule option. Click on this and it will convert to your device structure into the molecular structure. You can see. And if you want to convert to the crystal, click on this and you have to define the unit cell vector like 23 and give the value here and click on build. It will show the unit cell basically here to convert to crystal option. To create the grain boundary, go to the build option. There is option for the grain boundary you can create. Click on this and you can find like coincidence site lattice and you have to give the angle also. And you can assign the orthogonalization also and click on preview. You can see it will create the grain boundary also of the same material file and click on build option. For this, build option, you can create multiple things, like you can create 3D molecular structure, 2D molecular structure. You can create convert to device option, bending of device. It means you can create flexible devices also. You can create the interface builder, means through the interface builder, you can create interface between two different material files. And CAD to atomic option, it means two or different material, you can create the interface. Through the crystal option, you can create your own crystal file. And through the redefine, you can redefine your supercell structure. And through the standardized cell, it basically convert to the primitive cell. If I click on this, like this one, it will convert to the primitive cell, to the standardized cell option. And through the symmetry option, it will give the information related to the crystal. You can see name, space group, 3D crystal, their long name, crystal system, and their operator also here. Again, in the build tab, you can create the nanoribbon structure, nanotube structure through the build tab, and you can create the grain boundary also, and you can create the nanotube structure of any material file through the nanotube structure. And you can create disorder graphene like structure and disorder jig blend like structure. Cubo-octahedron, you can create bond option given here. You can also convert your file. It means if your material is present in Python file, you can also convert into the HZW XYZ also. It means import your Python material file and you can import into the XYZ also. So the convert to HZW option. Again, let's import any other material. Let's find the parameter related to the boron nitride and go to the simulator, rescue. You can see the relax option also. If you want to minimize your structure file, you have to move to the relax option, and you can see you have to give the value like sigma value, resolution, exchange correlation function. And in the relax method, you can see some of the method given: cosine Newton, conjugate gradient, and stepen descent. You can choose according to your own material file and give the force convergence criteria also here, basis set and spin type. Click on generate file. Here you can see in rescue crystal, it will create the relax.input file. If I click on this and open with, you can see the script also. And you can see the calculation type, relaxation, where will the result will be saved in the result folder, lattice vector. And you can see the method also, like serial method, cosine Newton, and their tolerance level also you can see here. Right click and click on run. Here you can see in the job manager, you can see the description, boron nitride, and relax.input file in running condition. You can see the script also, the process also, like it started generating atom orbital subspace. It will take some time to relax your structure, basically boron nitride structure. Again, in the simulator tab, rescue, you can see the SCF calculation and DFPT. Let's create the SCF first and click on generate file. Run. And again in the simulator, let's find the other parameters also, like potential. Here you can choose the potential also, like heart rate potential, atom effective potential, and other type of potential you can find. And click on generate file. In the job manager, you can see relax.input in running condition. After that, SCF input file will be run. Then potential.input file will be in running condition. You can see relax.input completed. To see the relax structure, click on relax.input file and click on open containing folder. It will open a new folder. Here you can see relaxation interposes text file. If I click this and click on open, you can see the relaxation iteration step like total energy and their atom specification, coordinate, y coordinate, z coordinate, and their force also. And you can see the process for the structure relaxation here and the total time also. Here you can see the relaxation process is also and relax structure.xyz. It means relax material file here. Go to the file option, import, import local, and go to the your project folder basically. Device studio project and go to the here you can see tab workshop. Click on this. Go to the boron nitride rescue crystal. Here you can see relax structure.xyz. Click on this and click on open to import your relax structure material file. Here you can see the relax structure for a boron nitride. After that, you can run the SCF input and find other parameters also. You can see the potential.input file. Open with and remove the result here. Save and rerun the potential.input file. To see the data related to the potential.input file, you can see the potential for boron nitride. You can choose the ISO value also. (2D) for spin up and spin down also, and 1D like average plane along XY plane, YZ plane, and XZ plane. You can also import in text file and image format also. Here you can see the structure refinement model. It means you can refine your structure also, like their colors and their angle for a image for a research paper. You can choose the structure and refine your structure also. Like you can choose different color like white and click on OK. You can increase the radius also. You can see. You can create the polyhedral model also. You can choose different type of bond, multiplier, and lightning also to refine your model also. And for paper published image, you can generate from here also to the structure refinement model. You can see structure refinement module. You can directly import image in PNG format. And now you can see in the desktop folder. Here you can see. Let's show other result also for a rescue software. Here basically we find the Berry curvature for a boron nitride, and we run the rescue crystal file SCF input file, and after that we create the interface and run the SCF input file. To see the data related to the Berry curvature, we have to move to the MATLAB and see the data also. You can see the Berry curvature for the boron nitride here. You can see the data also. And you can see the mat file also here. You can find the answer. This you can see the variable here. Like if I type Berry, you can see the data also, their band range and their value also. Same for the graphene you can find. You can see the interface.mat file. You can see the data also here, like their energy, force. If I type force, you can see the value also. You can see all the data related to that. Let's see the data for the scanning tunnel microscopy project. It will show some result. I'll show you. You can see it will generate some mat file like stm template.mat file, lco.stm.mat file. I directly show in the documentation. Where is the HTML related example? Where we can find the HTML related parameters. First, we find the PDOS. After that, we find the HTML simulation results. So this you can see this type of data you can find easily. HTML map analysis. And this type of graph also you can find. You can see the parameters related to the scanning tunnel microscopy in input reference. Here you can see self-consistent calculation and post-analysis you can see here. And for molecular dynamics and relaxation you can see. For up to now, if anyone have doubt, please ask. You can directly to see the battery related material file. Go to the file option, import local, and you can see the lithium related parameters also. Lithium material file, if you can see here. You can see Li2CO3, directly import from the open source and click on open. It also using the battery material related parameters. You can directly simulate and find the property also related to the battery materials. Anyone else who have query related to the software or other material file, please ask. You can send your query in the mail also. I send in the chat box also, like support@impulsetechnology.in. You can send your query also here. Anyone ask related to the cerium oxide material for the antibacterial activity? Go to the file option, import local, and in 3D material, you can see the metal oxide. Here you can see the some metal oxide material also. And you can find the direct import your material file. And you can find the properties also. Like if you're asking for the cerium oxide, here you can see. You can directly import and you can create a supercell also if you want. And you can find the directive properties also through the rescue software. Yes, sir, you can do magnetic properties also here to find, you can see here. If I go to the file option, import local, and in 3D material, some magnetic material also given. You can see here. Like you can, you're asking about FEO. If I click on FEO, and you can change also, like oxygen to the nitrogen. And now you can simulate also to the simulator, rescue, SCF, and in spin type, here you can see, click on collinear spin, and you have to give the maximum value. And if you want to the spin orbit interaction, click on general spin, and you have to give the value here. And you have to, if you want to include spin orbit interaction, click on this and click on generate file. I also saw some example also.
Can you show me some magnetic material like magnetic alloy, permanent magnet alloy, something like that, like aluminum alnico or NDFEB alloy, something like that?
Okay, sir, I'll show you. In 3D material, if you can see some magnetic material here,
Yeah.
the list of magnetic material like CO3 Fe and Dy Fe, Fe2O3, you can see some of the material given. Apart from that, if material is not present here, you can directly import from the online database also.
Okay. Okay.
There is option import online option. Directly write your formula here and
Hmm.
click on search. If you give the formula of your material, I'll directly search here.
It is NDFEB,
And
neodymium iron boron. Like,
could you please write in the chat box?
yeah.
Okay. Basically, in the online database, also material not present, but we can create also material file for the magnetic material also. For this
Okay.
also,
So if I
I
have a postcard of NDFEB, I can, could I able to import that one?
what sir?
Postcard.
Yes, sir. You can directly import in Device Studio GUI because it support this type
Okay.
format also.
Hmm. Okay.
Here you can see it support the postcard also.
Okay. Hmm. Great.
It support
What are the,
what sir?
sorry to interrupt, what are the outcome of this magnetic material simulation property? Like there will be some um, something, the magnetic properties like magnetic energy anisotropy, something, MEA property, something. What is the outcome of that magnetic material?
You
Or
can
would be the
find.
result?
I'll show some example also, sir.
Yeah.
Currently, sir, in my system, the project is not, but I'll share the project also for the magnetic related properties.
Okay. Okay.
Anyone else? Can we identify magnetic property using software material like? I have to check, then I'll let you know. Anyone else who want the trial version of this software, they can directly mail us for a trial version of this software. I hope everyone received the mail also in the chat box. You can mail us at support@impulsetechnology.in. And I also give the number in the chat box. If anyone have query, you can easily ask.
Sure.
Okay.
No, sir, it is not
Just
free
if you
software.
can, yeah, share that the magnetic property. I'm working on the permanent magnetic materials. So it would be great, like if you can able to share the magnetic problems and let me go through it, and I can also try and evaluate the tool.
Okay, sir, no issue. Anyone else who have query? Please ask. You can directly contact us for the regarding the software for trial version and for the cloud also. Let me share the number also and email ID in the chat box.
Hello, so I do have one question.
Yes, sir.
So like I'm working on 2D materials, and due to
Yes,
some
sir.
reasons, due to some environmental conditions, there are some degradation in
Yeah.
material. And
Okay.
experimentally, I want to find the local density of states as we do in
Yeah.
STS. Or so, is that possible to simulate these kind of things in this type of software?
Yes, easily you can find the LDOS also here, and you can use the like 2D material also. I'll show you also. If you go to the file option, local, and some 2D material given here.
So it's like
Like
molybdenum disulfide.
yeah, you can directly import any other material also, and in
Okay.
the simulator rescue, first you have to run the SCF,
Okay.
and after that in analysis density of state you can see local DOS, LDOS you can find by giving the energy of local DOS.
Okay. Okay.
In tomorrow's session, basically we go through the nanodical software, which is used for the quantum transport and material also, where you can find the IB curve and other parameters also. It is used for the devices where you can create biomolecular devices, gas sensor type of devices, probe devices, and you can simulate find LDOS, PDOS, and TDOS also you can find. I showed some the analysis function also in the nanodical. You can find all these type of parameters like density of state, effective potential, total energy you can find, charge, Hessian, phonon band structure, potential, eigenstate you can find, thermoelectric transport, modulus, force, stress, all these type of parameter you can find in nanodical software. Please come into the
Thank
tomorrow
you.
session also for device
Sure,
structure.
sir. Thank you so much, sir. Thank you so much, sir.
Thank you everyone for joining the session.